Now, before the break, we looked at bumblebees, we looked at solitary bees, we looked at overwintering strategies and native bee anatomy. Now we're going to resume with a short bit about bee stings, and I want you to know that only females can sting. Now you guys think about a world in which only the women have weapons. You begin to get an insight into how it works for bees.
Whoa, baby.
The drawing is mine, but I drew it from life. And notice that there's no barbs on this stinger. Only honeybees have barbs. Wasps and all the native bees have smooth stingers, and they can do it the three-way sting. It's long, deep, and repeatedly. If you hassle them, look at the mustache. It's got a mustache. Almost all the rest are honeybee stings, and the honeybees die when they sting you. Native bees seldom sting people. I teach people in my courses when I take you out in the field, everybody gets to pet a bumblebee. And if you pet them like a cat, you pet them the right way the fur goes, they have three choices. They'll either ignore you, shoulder you out of the way, and keep on doing what they're doing, or they'll fly to a different flower. But neither I nor anybody in my classes in the last 10 years has ever been stung petting a bumblebee, because they just don't sting you. Males camp out every night because they don't get to come back home, and they camp out every night until they die. And sometimes you see the males out, and in the morning when it's cold, these males don't brood eggs. They don't have the ability to maintain the heat that the females do. And so they end up staying out all night on their own, sometimes in groups, until they die. In North America, there's about 4,000 species of native bees co-evolved with 30,000 species of plants. Coevolution. So how the plants changed affected the bees that could service the plants, and how the bees changed affected the plants they could service. And it's a mutual arrangement. So we end up with big bees and small bees. And so if we look on our handout, find number 1 on your handout. Now remember, that's a life-size picture. That's the size the bee actually is on your handout. And compare it with number 50 down in the corner. And what you see is Bombus nevadensis queen, number 50, compared to Laciglossium sp. There's a big difference in the size and color and behavior, and that's from coevolution over thousands of years, so that the meadows that we looked at to start with that had a wild profusion of flowers also had a wild profusion of bees to support those flowers. So we've got short tongues and long tongues, and in fact we divide bees up into the short tongue group and the long tongue group. Here's a short tongue bee, Nomia melandri, working on a flower that only needs a short tongue. And this is a long tongue bee, and there are some flowers that you gotta have long tongues or you're out of luck. So we look at a simple little flower that's out in the spring right now, and you look at where the flower starts, the petals up here, but the nectary is clear down here. Now what's in the nectary? Nectar is in the nectary. What's nectar? Nectar is flight fuel. When you've driven 400 miles in your car, you've got to pull into a gas station and fuel up. You put in gasoline. The bees put in nectar. That's flight fuel. And that's why wasps will visit flowers, because they got to have the flight fuel. They aren't good pollinators at all. Most butterflies aren't pollinators at all, but they visit the flower because they got to have flight fuel. So everybody visits the flower to get the flight fuel, and a few of them are able to pollinate. But notice how the structure of the flower, where the pollen is here, in order to get to the flight fuel, you got to pass by the pollen, and when you go to the next flower, you do the fertilization that's necessary for the flower. Isn't that cool? That's how that works. So here we have a bee that's approaching the flower, and you see she's bringing her landing gear down. She's got her gear out. She's going to hook on this part of that petal. This front leg is going to go over this part of the petal, and look at the antenna there, the mouth parts starting to come out. But the mouth parts slide clear up into the center of the thorax, and those will slide out and go all the way down to here to the nectary on the long-tongued bee. So if we take a look at what happens next, here she is, and she's reaching all the way down to the nectary down here with that long tongue. 5 different ways to carry pollen home to feed the babies. That's what the females are doing. They're working their little buns off carrying pollen home to feed the babies, and then they die. That's how that works. 5 different ways. We got the way that the honeybees and the bumblebees do. They carry it in satchels on the side. We got the ones that have a rug on their tummy that you heard about in the song before we started this program. This pollinator in an apple orchard is 70 times as efficient as a honeybee because the honeybee's pollen is in those satchels on the side and it's out of play. And when this bee lands on the flower and it's got this pollen just stuck into those hairs, it's like that teenage kid who was out playing in the mud. When they walk through the kitchen and into the bathroom, you can see exactly where they went because they're sloppy. And so we've got bees that carry pollen are way more efficient pollinators than honeybees. These are native bees. Some of them carry it amidships. Now, did I tell you about the problem of weight and balance and having the load in a place where your wings can carry it? And so different kinds of bees have different kind of relationships between their wings and the rest of the body. And here we've got a problem where we solve it by putting all of the pollen amidships, and we're able to carry massive loads home, and we don't have so much hanging out on the edges of the legs. Take a look at your handout on number 2. Number 2 is Hylaeus species. There's 2 species. Number 4 or 5 is also Hylaeus. That's a small species. So this one has it's like the South American gaucho with woolly shafts, and it's got big loads on both hind legs, all around the hind legs. So they got a different relationship between the load they're carrying and where the wings are. Now we look at, on your handout, we look at Hylaeus number 2. And here's number 2, Hylaeus. Hylaeus is a tiny little bee. But I don't see any fuzzy hairs on this one, no plumose hairs. Cletidae, where's the pollen? Well, it's in a pollen crop. And what they do is they put the pollen in their mouth. There's a tube that goes down through the thorax. The thorax is different on them. See, in us, we got heart, lungs, liver, and all the organs here in the center, and that's where it's all important to us. But in the bees and wasps and ants, that's all muscles. Locomotion muscles, flight muscles. And there's a little tube that goes all the way down into their abdomen, and that's where all of their organs are, in their abdomen. So there's what we call a pollen crop that they have to put it all the way down that tube into this pollen crop. Anybody know how mama wolves bring home chunks of meat for their baby wolves? They swallow it down and then they regurgitate it when they get home. And that's exactly what Hylaeus does, just like mama wolves. They swallow it down and regurgitate it when they get home and put it into their stuff for their babies. Now we've got generalists and specialists. Remember, we have thousands of bee species and hundreds or 30,000 plant species. And we've got some that are like crows and they can eat anything. And then we've got some that are like hummingbirds that can only eat certain things with a little tiny hole that they get into. So we got generalists and specialists. So there's a spectrum from bombus bumblebees that are pretty much whatever you've got, they have a way of getting to it, down to Didatium and Nidifrons, which is here in Washington. There's 4 species. And if you don't have the right flower species, you can't have Didatium and Nidifrons. You need a globe mallow, you need specifically a Lamnia longicephala, or you don't have that bee. That's called a ligalactic, and that's another one of those words that's really tough to get into after dinner conversation. Okay, flower visits are necessary and beneficial both for flowers and for bees. The bee benefits. Nectar, let me see if I think I did that. Nectar, flight fuel, pollen, and bee food. The pollen is the food. But flower visits are dangerous for the bees. There's predators out there, lots of them, spiders. This spider is so well camouflaged that unless you know what you're looking for, you might not even see it. Here's how many legs? 1, 2, 3, 4, 5, 6, 7, 8 legs. That's a spider, all right. But it sure is well camouflaged. Now, did I tell you about how bees are usually pretty much focused on their job? That's a risk. This bee is focused on her job. See any trouble coming up? 1 leg, 2 legs, 3 legs, 4 legs. I'd say that there's some trouble coming here, and this is dinner. Bee wolves. There's a whole group of wasps that make their living catching bees and bringing them home, but they don't kill them. They don't kill them. Don't worry about that. They don't kill them. They just sting them in a way that paralyzes them. And they don't have refrigerators, and they got to feed their babes, and so they got to have some way to make this last through the entire food cycle necessary to grow those larvae all the way up to their pupal stage. And the way that the bee wolf does that is it paralyzes the bee And then it takes it home and puts it in this little chamber and lays one egg on it, and the egg starts eating on the non-vital parts. And it doesn't eat all the vital parts up and kill the bee until it's ready to go into the pupal stage. There's birds out there that are problems. Who knows what this bird is? Somebody can tell me. It's a shrike. There's two species of shrikes, loggerhead and another species of shrike in Washington. And what shrikes do is they catch little mice and grasshoppers and other things, and they go find a fence that's got barbs on it, and they pierce them right onto that barb and leave them lay there. And that's the fate of that bumblebee queen that got caught by a shrike. Insecticides out there, neonicotinoids, I could spend the whole evening talking about those. Parasites, mites. Remember those honeybees that have to live in a colony and everybody gets the same disease and everybody gets a mite? Well, everybody's got mites. And they go visit the flowers, and then those mites jump off the flower onto the bees. And so I find some of my mega pilots looking like this. And each one of those mites has got a little tube like a mosquito, and drills a little hole in the outside of that body, sticks his tube down inside and goes and sucks all the juices out. And when you get all the juices sucked out, you die. And that's what happens to you. And then we talked about the kleptoparasites that lay their eggs in your nest. Life ain't easy for native bees. There's problems out there.